The Transport Shuttle Academy Meridian drifted silently through the cold darkness of space, carrying 23 nervous cadets toward their final examination. Through the thick windows, the harsh surface of Kepler 442c stretched below them like a gray wasteland dotted with deep craters and jagged rocks. Professor Veltar stood at the front of the observation deck, his tall blue frame commanding attention from every species present. His crystal-like skin caught the artificial light as he reviewed his tablet one final time. After 30 years of teaching survival engineering, he had seen thousands of students face this moment. Most passed. Some failed spectacularly. A few surprised him. Today felt different somehow. Listen carefully, the professor began, his voice carrying easily through the recycled air. In exactly 1 hour, you will be transported to the surface of Kepler 442c. This moon is known for 3 things: unpredictable weather, frequent meteor showers, and absolutely no mercy for poor planning. A nervous chittering sound came from the back of the group where the insectoid Krelix students huddled together. The twin Valerians, with their smooth gray skin and large black eyes, remained perfectly still as they calculated angles and wind resistance in their heads. Near the front, a delicate Alpharan female named Whisper Song hummed a soft melody to calm her nerves. Your mission is simple, Professor Veltar continued, walking slowly between the assembled students. Build a shelter. Basic requirements: 4 walls, environmental seal, life support for 72 hours. Minimum internal space of 15 cubic meters. You have access to standard emergency supplies only. Most of the cadets were already making mental notes about construction priorities and power distribution. The Nethys Collective, sharing thoughts through their natural telepathic link, had begun coordinating their approach before the professor finished speaking. The Christech student called Bright Edge was calculating material stress ratios with the precision of a living computer. But in the back corner of the shuttle, human cadet James Harrison was doing something entirely different. While his classmates focused on meeting minimum requirements, James scrolled through the supply manifest on his tablet with unusual interest. His brown eyes moved quickly down the list, pausing occasionally to make notes. Power cells, structural plating, atmospheric processes, emergency rations, medical supplies, communication equipment, toolkits, and dozens of other items that most students would use exactly as intended. James saw possibilities. The weather on Kepler 442c changes without warning, Professor Veltar explained, projecting a holographic image of the moon's surface. Temperature swings of 40 degrees are common. The thin atmosphere provides little protection from radiation or impact debris. And the electromagnetic field fluctuates constantly, which means your electronics may fail at the worst possible moment. Several students shifted nervously. Building a shelter was one thing. Building a shelter that could survive Kepler 442c was another challenge entirely. James made another note on his tablet. His roommate, a friendly Altarian named Kordesh, leaned over to see what had captured the human's attention so completely. Planning your construction sequence. Kordesh asked in his species' characteristic whistling language. Something like that, James replied, not looking up from his screen. Just reviewing what we have to work with. Kordesh glanced at the manifest James was studying. Looks like standard emergency supplies to me. Enough for basic shelter construction with maybe 10% surplus for mistakes. James smiled slightly. Yeah, that's what I thought too. Very generous allocation. Generous? Kordesh's head tilted in confusion. The Academy calculates these supplies precisely. There should be just enough for minimum requirements. Exactly, James said, but his tone suggested he was thinking about something completely different. Near the front of the shuttle, Professor Veltar was describing the various ways previous students had failed the examination. Structural collapse due to poor foundation planning. Life support failure from inadequate power management. Complete destruction during meteor impact because someone forgot to calculate trajectory probabilities. The key to success, the professor concluded, is meeting the requirements efficiently and safely. Do not attempt to exceed specifications. Do not try to impress the evaluators with unnecessary complexity. Build what is needed, nothing more. James looked up from his tablet for the first time since the briefing began. Professor, what exactly defines unnecessary complexity? Several students turned to look at the human. Professor Veltar paused his presentation, his crystal blue eyes focusing on James with interest. An excellent question, Cadet Harrison. Unnecessary complexity would be any system, structure, or function that exceeds the basic requirements of the assignment. You need shelter for 72 hours, not a permanent installation. You need life support for one occupant, not a crew of 20. You need basic protection from the environment, not a fortress designed to withstand military assault. James nodded seriously. Understood, sir. Just want to make sure I stay within acceptable parameters. Very wise, Professor Veltar replied, though something in the human's tone made him slightly uneasy. In his experience, when students asked about the boundaries of an assignment, they were usually planning to test those boundaries. As the shuttle began its final descent toward Kepler 442c, the 23 cadets prepared for the challenge ahead. Most checked their basic tool allocations and reviewed standard shelter construction procedures. The more experienced students ran final calculations on power efficiency and material distribution. James Harrison closed his tablet and stared out the window at the approaching surface of the moon. Somewhere in his mind, blueprints were taking shape. Plans that would use every single item in that precisely calculated supply manifest. Plans that would redefine what the Academy considered basic shelter requirements. But for now, he kept those plans to himself and smiled at the gray wasteland below. After all, humans had been making themselves at home in impossible places for thousands of years. How hard could one little survival test really be? 6 hours into the examination, the surface of Kepler 442c looked like a construction zone scattered across several square kilometers. 23 different approaches to basic shelter building were taking shape under the pale light of the distant sun. The Valerian twins had already completed their sleek, dome-shaped structure. Its smooth gray surface gleamed like polished metal, designed to deflect meteor impacts and channel wind around its curved walls. They worked with mechanical precision, each movement calculated for maximum efficiency. Near the eastern ridge, the Nethys Collective had grown something that barely looked artificial. Their biodome seemed to sprout from the rocky ground itself, its living walls pulsing gently as they converted atmospheric gases into breathable air. Green veins of bioluminescent material traced patterns across its surface like glowing circuit boards. The insectoid Krelix students had built upward, their tower-like shelter rising 15 meters into the thin air. Multiple levels connected by spiral ramps, each section designed to serve a specific function. It looked like a termite mound crossed with a radio antenna. And then there was the human. James Harrison was digging a hole. A very large, very deep hole. His Elfaran teammate, Whispersong, perched on a nearby boulder and watched the excavation with growing confusion. Her delicate features showed concern as James disappeared completely below ground level, his digging sounds echoing up from the depths. Human James, she called down in her musical voice, perhaps there has been some misunderstanding? The assignment requires us to construct shelter above the surface, not below it. A shower of dirt and small rocks flew up from the pit, followed by James's voice. No misunderstanding, Whisper. Just taking a different approach. But the other students are building upward. Their structures are nearly complete while you continue to dig downward. How will this help us pass the examination? James's head appeared at the edge of the hole, his brown hair dusty and his face streaked with dirt. Despite the environmental suit's climate control, sweat beaded on his forehead from the physical exertion. See, that's where you're thinking like everyone else, he said, wiping his face with the back of his hand. Everyone's building up because that's the obvious thing to do. But obvious isn't always smart. Whispersong tilted her head, a gesture of confusion among her people. I do not understand. How is building underground better than building on the surface? James climbed out of the pit and gestured toward the other shelters scattered across the testing area. Look around. What do you see? I see many different shelter designs. Some are quite beautiful. Right. And what do they all have in common? Whispersong considered this carefully. They are all visible. Exactly. James pointed at the Valerian dome, then at the Krelix tower, then at several other structures. Every single one of those shelters is sitting out in the open like a target. When the next meteor shower hits, or when the temperature drops 40 degrees tonight, or when those electromagnetic storms start messing with their power systems, they're all exposed. He gestured down into the pit, which had grown to impressive dimensions. Nearly 4 meters deep and 6 meters wide, with what looked like tunnel entrances branching off at precise angles. Underground means protected. Underground means stable temperature. Underground means when something nasty happens up here, we're safe down there. Whispersong peered into the excavation with new interest. This is quite extensive for a simple shelter. Yeah, well, humans don't really do simple when it comes to staying alive. From the depths of the pit came the sound of metal on stone, steady and rhythmic. James had fashioned some kind of digging tool from a plasma welder and a piece of hull plating from the supply cache. It cut through the rocky soil with remarkable efficiency. What are those tunnels for? Whispersong asked, pointing to the branching passages that disappeared into darkness. Storage, backup systems, emergency exits, that kind of thing, James replied casually, as if excavating a tunnel network was perfectly normal for a basic shelter assignment. Always good to have options. By the 12-hour mark, while other students struggled with the moon's temperature differential and power management issues, James had successfully pressurized his main underground chamber. Soft lighting illuminated walls that had been smoothed and reinforced with structural plating. The space felt warm and comfortable, a stark contrast to the harsh environment above. But what caught Whispersong's attention was the device in the center of the chamber. "Human James," she said slowly, "what is that machine?" James looked up from where he was calibrating a complex arrangement of pipes, heating elements, and what appeared to be repurposed atmospheric processing equipment. Steam rose gently from a small spout, and a rich, aromatic scent filled the underground space. "Coffee maker," he said proudly. "Built it from the emergency ration heating elements, some atmospheric processing components, and a few other bits and pieces. Want to try some?" "Coffee maker," Whispersong repeated, as if the words didn't quite make sense together. "You have constructed a beverage preparation device." "Best coffee maker you'll ever see," James confirmed, pouring dark liquid into a small cup and offering it to his teammate. "Humans take their coffee seriously. Figure if I'm going to be stuck somewhere for 3 days, might as well have good coffee." From the observation shuttle high above, Professor Veltar watched James's progress through long-range sensors. His initial amusement had given way to genuine fascination as the human's simple shelter revealed itself to be something far more complex. "Most unusual," he murmured to his assistant. "The human appears to be treating this exercise as if he expects to establish a permanent base of operations." What Professor Veltar couldn't see yet were the motion sensors James had installed around the perimeter, or the automated systems taking shape in the secondary tunnels, or the power grid that was already operating at triple redundancy. James Harrison wasn't just building a shelter. He was building home. And home, for humans, meant being ready for anything. What had started as James Harrison's mysterious underground excavation had transformed into something that defied every category in the Academy's evaluation handbook. Motion sensors, carefully disguised as simple maintenance equipment, tracked movement across a 100-meter radius around his position. Automated systems hummed quietly in the depths, managing power flow, air circulation, and temperature control with military-grade precision. Professor Veltar descended into the main chamber through what James called the primary access shaft, but looked more like the entrance to a command bunker. The professor's crystalline features reflected the soft blue lighting that illuminated reinforced walls and gleaming metal surfaces. "Cadet Harrison," Professor Veltar said carefully, his voice echoing slightly in the surprisingly spacious underground area, "perhaps you could explain exactly what you have constructed here." James looked up from a control panel that seemed to monitor at least a dozen different systems simultaneously. Green lights blinked in steady patterns while data streams scrolled across multiple screens. The rich aroma of fresh coffee filled the air, stronger now than it had been 12 hours earlier. "Well, sir," James replied, wiping his hands on a cloth, "you asked for a shelter with basic life support. This provides shelter from all environmental hazards. The atmospheric systems maintain perfect air quality, temperature, and humidity levels regardless of external conditions. The power grid operates on 3 separate backup systems, so we'll never lose life support even if 2 systems fail completely." Professor Veltar walked slowly around the chamber, taking in details that shouldn't have been possible with standard emergency supplies. The walls were reinforced with structural plating arranged in patterns that would deflect impact damage. The ceiling curved gracefully, distributing weight loads with architectural sophistication that belonged in permanent installations, not student projects. "And this?" The professor gestured toward the center of the room, where an elaborate device occupied a place of obvious importance. "Coffee machine, sir," James said with unmistakable pride. "Took some work to get the pressure ratios right, but she brews perfect cups every time." The device in question was a masterpiece of improvised engineering. Components from life support systems, emergency ration heaters, atmospheric processors, and communication equipment had been combined into something that looked like it belonged on a luxury starship rather than a survival shelter. Steam rose gently from its polished surfaces while mechanical sounds indicated complex internal processes. "A coffee machine," Professor Veltar repeated slowly, as if saying the words might help them make more sense. "Yes, sir. See, humans have this relationship with coffee that's hard to explain to other species. We can handle almost any situation as long as we have good coffee. Bad coffee makes everything worse. No coffee. James shook his head seriously. That's when things get really dangerous. Professor Veltar made several notes on his tablet, most of them involving questions he wasn't sure how to ask. Cadet Harrison, this installation appears to exceed basic shelter requirements by a considerable margin. How so, sir? Well, for instance, what is the purpose of these tunnels? The professor pointed toward passages that branched off from the main chamber in multiple directions. Storage and backup systems, mostly, James replied, as if excavating a tunnel network was standard procedure. That one leads to the secondary power station. This one goes to the workshop area where I've got fabrication equipment set up. The one over there connects to the observation post. Observation post. Small chamber about 50 meters that way, with sensors and communication equipment. Good view of the whole testing area through the periscope system. Helps keep track of what's happening on the surface. Professor Veltar was beginning to understand that his definition of basic shelter and James's definition were separated by several orders of magnitude. And these displays. He gestured toward screens showing various data streams. Environmental monitoring, power systems, external sensors, communication arrays, that sort of thing, James explained. The computer system tracks everything automatically, but I like to keep an eye on the data myself. Above ground, the other 22 students were dealing with the normal challenges of Kepler 442c's hostile environment. Temperature fluctuations stressed their heating systems. Power cells drained faster than expected. Communication equipment suffered interference from electromagnetic disturbances. Below ground, James Harrison sipped perfectly brewed coffee while monitoring it all through sensors that shouldn't have existed, powered by systems that defied supply calculations, protected by walls that could probably withstand direct meteor impact. Cadet Harrison, Professor Veltar said finally, exactly what did you think this examination was testing? James considered the question with obvious seriousness. Survival skills, sir. But humans don't just survive situations. We adapt them. We make wherever we are work for us instead of against us. We turn problems into advantages. He gestured around the chamber with genuine enthusiasm. This isn't just shelter, it's home. Safe, comfortable, functional, and ready for whatever happens next. Because that's what humans do. We don't just get by, we make things better. Professor Veltar looked at his tablet again, then at the coffee machine, then at the displays showing system status for equipment that officially didn't exist. Somewhere in the Academy handbook was probably a regulation about students exceeding assignment parameters by 4,000%. He made a note to find that regulation later. Your coffee machine appears to be the most sophisticated piece of equipment in this entire installation, he observed. Well, sir, James said with a slight grin, priorities are important. Everything else keeps us alive, but the coffee machine makes life worth living. From the surface above came the faint sound of wind picking up as Kepler 442c's weather began its daily shift toward the unpredictable. Other students would soon be dealing with power fluctuations and structural stress. Down in Harrison Base, as the facility was already being called by Academy observers, the coffee machine continued its perfect brewing cycle while automated systems prepared for whatever challenges the moon might throw at them. James Harrison had built more than shelter. He had built proof that humans approach survival with a fundamentally different philosophy than the rest of the galaxy. They didn't just survive. They thrived. Day 3 dawned with an ominous change in the atmosphere of Kepler 442c. The pale morning light carried a strange flickering quality, and the thin air seemed to vibrate with invisible energy. Electromagnetic readings across the testing area began showing irregularities that made the Academy monitoring team increasingly nervous. By mid-morning, what had started as minor interference became something much more serious. The storm began quietly. Communication systems across the testing ground started experiencing static. Power fluctuations appeared in several student installations. The Krelix Tower reported strange humming sounds in their structural supports, while the Nethys Biodome's living walls began showing stress patterns they had never seen before. Within 2 hours, Kepler 442c was unleashing the worst electromagnetic storm in Academy testing history. Lightning crackled across the gray sky in colors that shouldn't have existed. The thin atmosphere became a canvas of dancing electrical discharge that made navigation equipment spin wildly. Meteor activity increased dramatically as the electromagnetic disturbance somehow attracted more space debris into collision courses with the moon's surface. Emergency alerts began flashing on every cadet's display system. Then, one by one, those display systems started failing. The Valerian dome, with its sleek design optimized for meteor deflection, found itself overwhelmed by electrical surges that fried its main power systems. Emergency lighting flickered and died, leaving the twins in darkness as their environmental controls began shutting down. The Krelix Tower, rising high into the chaotic sky, became a lightning rod for electromagnetic discharge. Sparks cascaded down its spiral structure as level after level lost power. The insectoid students huddled in the lowest section, watching their carefully planned systems fail in sequence. Across the testing area, 17 different shelter configurations reported critical system failures. Emergency protocols activated as students faced the terrifying reality that their basic shelters were not equipped to handle this level of environmental hostility. Then a calm voice cut through the chaos on the emergency communication channel. Academy Control, this is Harrison Base. I have visual confirmation of multiple shelter failures across the testing area. Initiating emergency assistance protocols now. Professor Veltar, monitoring from the observation shuttle, stared at his instruments in disbelief. While every other communication system struggled with interference, James Harrison's signal came through perfectly clear. Cadet Harrison, what is your status? Professor Veltar asked, trying to keep the amazement out of his voice. All systems operating normally, sir. Coffee's still hot, power grid is stable, and my sensors are tracking the storm patterns pretty accurately. Looks like it's going to get worse before it gets better. From his underground command center, James Harrison sat calmly at his control station, sipping fresh coffee while monitoring 17 different data streams. Around him, his impossible installation hummed with quiet efficiency. The electromagnetic chaos raging overhead had no effect on his deeply buried systems. Harrison Base, we're showing critical failures in shelters 7, 12, and 15, came the urgent voice of Academy Control. Those students need immediate evacuation. Understood, Control. Beginning shield extension in 3, 2, 1, now. Above ground, something extraordinary happened. Energy barriers, powered by James's over-engineered power grid, expanded outward from his position like protective bubbles. The shimmering fields enveloped the 3 nearest failing shelters, immediately stabilizing their environmental systems and deflecting the worst of the electromagnetic interference. How is this possible? Professor Veltar whispered to his assistant. The answer came in the form of automated rescue drones that launched from concealed positions around Harrison Base. The small flying machines, constructed from maintenance equipment and supply containers, moved with purpose through the chaotic storm. They carried emergency power cells to failing installations and communication boosters to restore contact with stranded students. Meridian Control, this is Harrison Base. James's steady voice continued coordinating the rescue effort. I'm reading power failures in shelters 3, 8, 19, and 21. Dispatching emergency support now. More drones emerged from hidden launch bays, their flight paths carefully calculated to avoid the worst of the electrical discharge. Each carried specialized equipment, backup power systems, emergency atmospheric processors, communication gear, and medical supplies. Whispersong, safely housed in the main chamber of Harrison Base, watched the rescue coordination with wide-eyed amazement. Human James, how did you know this would happen? James glanced up from his displays, where he was simultaneously tracking storm patterns, managing power distribution to the extended shields, and monitoring the status of 19 different rescue operations. I didn't know specifically, he replied, taking another sip of coffee. But humans have this saying, hope for the best, prepare for the worst. Kepler 442c has a reputation for throwing nasty surprises at people. Seems smart to be ready for whatever it might try. The storm raged for 6 more hours. Lightning struck the surface repeatedly, leaving glowing scars in the rocky ground. Meteor impacts increased to levels that would have been catastrophic for surface installations. Electromagnetic pulses fried unshielded electronics across a 100-kilometer radius. Through it all, Harrison Base maintained full functionality. Its shields protected not just James and Whispersong, but 17 other students whose shelters had failed. Its communication array served as the emergency coordination center for the entire testing area. Its automated systems provided backup power, environmental support, and medical assistance to anyone who needed it. And in the center of the command chamber, the coffee machine continued brewing perfect cups with mechanical precision, a small symbol of human priorities in the face of planetary chaos. Status report, Cadet Harrison, Professor Veltar requested as the storm finally began to subside. All Academy personnel accounted for and safe, sir, James replied promptly. No casualties, no permanent equipment damage, and everyone's got hot coffee if they want it. Professor Veltar stared at his instruments one more time, then at the impossible data stream showing how one human student had single-handedly managed a rescue operation that should have required a full emergency response team. Outstanding work, Cadet Harrison. Truly outstanding. James Harrison smiled and raised his coffee cup in a small salute. Just another day at the office, sir. Though I admit, this was pretty exciting compared to most survival tests. Around him, Harrison bass hummed quietly in the aftermath of the storm, a testament to the human philosophy that there was no such thing as being too prepared. Especially if you had really good coffee. The Academy Review Board had convened emergency sessions only 3 times in its 400-year history. The case of Cadet James Harrison and what was now officially designated as Harrison Base marked the 4th such meeting. Dean Mordak, a distinguished Altarian whose 6 compound eyes could process multiple data streams simultaneously, stood before the massive holographic display that dominated the review chamber. The 3-dimensional image showed Harrison Base in all its impossible complexity: underground chambers, tunnel networks, defensive systems, power grids, communication arrays, and automated equipment that shouldn't have existed. Esteemed colleagues, Dean Mordak began, his voice carrying the weight of centuries of academic tradition, we face a situation without precedent in Academy history. A single cadet has transformed a basic survival examination into something that challenges our fundamental understanding of the word basic. The reviewing panel represented 12 different species, each bringing their own perspective to the unprecedented situation. The crystalline Velkari delegate hummed in harmonious tones that indicated deep thought. The gaseous Etherian representative pulsed with colors that suggested both confusion and admiration. Even the ancient keeper, whose species had designed the original Academy protocols, seemed uncertain how to proceed. Professor Veltar stepped forward to present his findings. The numerical data speaks for itself, he said, gesturing toward charts and graphs that filled secondary displays. Cadet Harrison's installation exceeds baseline requirements by approximately 4,000%. His power systems could support a research station for 6 months. His defensive capabilities match military-grade installations. His communication equipment has better range and clarity than our own shuttle systems. And the coffee machine? Asked Councillor Jextar, a practical-minded Valerian who preferred focusing on concrete details. According to our technical analysis, it is the most sophisticated beverage preparation device in Academy records, Professor Veltar replied with barely concealed amazement. It incorporates technology from 7 different systems, maintains perfect temperature and pressure control, and appears to be completely automated. The engineering required to build such a device from emergency supplies is remarkable. James Harrison stood calmly before the review board, still wearing his dust-covered environmental suit from the testing ground. His brown hair was messy from 3 days of underground construction work, but his eyes showed no sign of concern about the proceedings. Cadet Harrison, Dean Mordak addressed him directly, your actions during the electromagnetic storm saved 17 lives and prevented what could have been a catastrophic failure of our testing protocols. Your installation performed rescue operations, provided emergency shelter, coordinated communication between stranded students, and maintained full life support throughout conditions that overwhelmed every other shelter in the testing area. Thank you, sir, James replied simply. However, the dean continued, you also violated the fundamental premise of the examination. This was designed to test basic survival skills. Instead, you created a permanent installation with capabilities that exceed those of established research stations. James considered this carefully. Sir, if I may ask, what exactly makes something basic when it comes to survival? The question hung in the air for a moment. Several board members exchanged glances, realizing they were about to hear something that might challenge their long-held assumptions. Basic survival, Dean Mordak explained, means meeting minimum requirements efficiently. Shelter from the environment, adequate life support, protection from immediate dangers. Nothing more than necessary. With respect, sir, James said politely, that might be true for other species, but humans don't really work that way. We don't do minimum requirements when our lives are at stake. We do comprehensive solutions because we've learned that survival situations have a habit of getting worse without warning. He gestured toward the holographic display of Harrison Base. Every system I built had a specific purpose. The tunnels provided protection from surface hazards. The redundant power systems ensured life support couldn't fail. The communication equipment maintained contact with other students. The defensive systems protected everyone in the area when the storm hit. And the coffee machine. He paused with a slight smile. Well, the coffee machine kept morale high while we dealt with everything else. Counselor Yithara, whose species had contributed to Academy safety protocols for 2 centuries, leaned forward with interest. You anticipated the electromagnetic storm? Not specifically, James admitted, but humans have this approach to dangerous situations. We assume something will go wrong, so we prepare for multiple types of problems at once. It served us well throughout our history. The review board fell silent as they processed this explanation. The concept of preparing for unknown dangers by over-engineering every system was foreign to most galactic species, who typically preferred efficient, targeted solutions to specific problems. Very well, Cadet Harrison, Dean Mordak announced after consulting with his colleagues. Your unconventional approach has proven effective beyond any reasonable doubt. You are hereby advanced to the Tactical Engineering Program with full honors and a commendation for exceptional performance under crisis conditions. Professor Veltar stepped forward. I will be recommending significant updates to our supply allocation protocols for future examinations. It appears our precisely calculated supply lists contain enough redundancy for students with sufficient creativity to exploit. Understood, the Dean replied. Additionally, Cadet Harrison, your installation will remain on Kepler 442c as a permanent research station. The Academy is curious to observe how long your systems continue functioning. James nodded respectfully. Thank you, sir. I built everything to last. 27 years later, Harrison Base continued to operate flawlessly. Its original systems had been expanded 3 times to accommodate research teams, visiting dignitaries, and Academy officials who came to study the installation that had redefined their understanding of survival engineering. The underground complex now included laboratories, living quarters, recreational facilities, and a small museum dedicated to the examination that had changed Academy protocols forever. Visiting students from dozens of species came to learn about the human approach to problem-solving, which had become known throughout the galaxy as Harrison's principle. When faced with uncertainty, prepare for everything. And in the center of the main command chamber, the original coffee machine still brewed perfect cups with mechanical precision, a testament to human engineering priorities and the universal truth that some things were too important to leave to chance. The Academy's new survival engineering motto, carved in 12 different languages above the entrance to the department, read simply, build it right, build it to last, and never forget the coffee. James Harrison had gone on to design defensive systems for half the galaxy, retired as Admiral of the Terran Engineering Corps, and become a legend in survival engineering circles.